Okay, lesson 89, value problems. Remember those coin problems that you guys were guessing at to get your answers? Well, now it'll be a little bit harder to guess at. I guess you could, but if you are smart, you're going to learn how to do this method. Now, this one says, it's a little bit different than coin problems. Airline fares for flights from Tifton to Adele are $30 for the first class and $25 for the tourist class. So we're going to have two variables. We're going to have the number of first class and the number of tourists. Now as soon as we hit two variables, you have to think that we're going to need two equations. You need as many equations as variables. If the flight had 52 passengers who paid a total of $1,360, how many first class passengers were on the trip? Now you always need two equations when you're doing these problems. One will be the number problems, like how many coins or how many passengers or how many dresses or how many things. So we always do that one first. So the number of first class people plus the number of tourist people equals 52 people. So that's just your people equation. That doesn't have anything to do with value. Your next equation is all about value. So first class tickets are $30. So 30 times the number of first class passengers plus 25 for the number of tourist tickets. The total amount of money is $1,360. So if you take the number of first class tickets, say you have two of those, and they're times $30, that would be $60. And if we had three tourist tickets, that would be $75, and you can see that that's not going to give us 1,360. Now I guess what you guys did was you just plugged in numbers here until you got 1360. But let's try to do it by either elimination or substitution. So we're going to do it by elimination. I'm just going to multiply the first equation by negative 30. So we get negative 30, number of first class, minus 30, number of tourists, equals negative 1,560. Copy the second equation down. This is old stuff, huh? 25 number of tourists equals $1,360. Remember the second one's our value, $30, $25, $1,360. These cross out and we get negative 5. Number of tourists equals negative 200. Number of tourist tickets is 40. And they didn't want tourist tickets, they wanted first class. So we could have been smarter. If we would have multiplied this by negative 25, we would have eliminated the tourists and we would have got the first class ones. So the tourist is, if it's 40, then the number of first class would be 12. So the number of first class equals 12 tickets. And of course you can check these by substituting them back in. 12 plus 40 is 52, and then if you put it in the value equation, you should get 1,360. The next problem is a little bit different, but these are again similar to the coin problems. Watakasha's dress shop sold less expensive dresses for $20 each and more expensive ones for $45 each. So it's really similar to that first class and tourist class problem above. The shop took in $1,375 and sold 20 more of the less expensive dresses than the more expensive dresses. How many of each kind did they sell? So we're going to have two variables again. Number of less expensive and number of more expensive dresses. So first one, let's just do our value equation. Well, actually, let's do our number equation first. It says sold 20 more of the less expensive dresses than the expensive dresses. So the number of less expensive equals the number of more expensive ones plus 20. That has nothing to do with value, it's just the number of dresses. Now we're going to do our value one. We would do $20 times the less expensive plus $45 times the more expensive gives us the total amount sold you plug in how many less expensive and how many more expensive and multiply them by their appropriate value, you'll get how much they sold. And they tell us that they sold in dollars $1,375 worth of dresses. Now you can see this one's a substitution problem, where the last one looked more like an elimination problem. So you can do either one either way. So we're going to plug that in for number of less expensive. So we get 20 times number of more expensive plus 20 plus 45 times the number of more expensive equals 1,375. We distribute that, so we get the number of, so it'd be 20 more expensive dresses plus 400 plus 45 more expensive equals 1,375, and then we just combine 65 more expensive equals, and we subtract 400. Actually put an extra zero in there for some reason. Come on, I'll clean that up a little bit there for you. There you go. And then if we subtract 400 from that, we get 975. Divide both sides by 65. Number of more expensive dresses equals 15. And if we go back up to this problem, number of less expensive would be 20 plus 15. So the number of less expensive dresses is 35. So hopefully you do these the right way and don't just guess. So that's it for lesson 89.